morning students. Today we will be starting a new chapter, surface chemistry, and as you can see today I have not come up with the chalk to talk. Instead I have come up with something which I can let you know is just detergent, a foaming agent. Alright, it is a foaming agent or detergent. Now I am putting this broken pen with a circular lumen inside it. Now guess what I am going to do? I am going to play. What happened? Bubbles formed. Another time. Smaller bubble. Now if I change the shape of this lumen, say if I would have taken a square shaped lumen here, then would I have got square shaped bubble? Or if I would have taken a wire with a star shaped loop and then if I would have blown this detergent, would I have got star shaped bubble? No. We would have still got spherical bubble. Now what a bubble is? Bubble is a thin film of the liquid inside which the air which I am blowing is filled in. Then why it assumes a spherical shape? It assumes a spherical shape because the thin film of the detergent experiences a surface tension. It experiences a surface tension because the air inside it is lesser in quantity than the air outside it, and the intermolecular force of attraction in the liquid molecule, they are also trying to coherently pull each other. So two types of forces are acting here. One is cohesive force and there is adhesive force. The adhesive force is between the two interface, that means the air outside the bubble, air inside the bubble, and cohesive force among the water molecule. The water molecule is trying to, or the water film, or the film of the detergent containing water, or the water containing the foaming agent is trying to keep themselves with themselves itself, right? Because they have a cohesive nature. But it is also showing intermolecular force of attraction with the atmospheric air as well as the air filled inside the bubble. Now, since the atmospheric pressure is uniform all around, so it is forming a spherical shape. So irrespective of what will be the shape of the lumen from where the bubble will come out, the bubble will always be spherical in shape. This is because of the tension experienced by the molecules of the water. So there was a heavy water droplet in the bubble, so it bursted. So you can make it like this. Alright, let me try if it works with this or not. Alright, next is, you might have used this while you have done some kind of creative work, the brush. Now, see the bristles of the brush, they are all spread apart. Now, when I will put this inside, what is there in this glass? In this glass, water is there and air is there. Air is there inside this, water is there inside this. And this part is called as interface, the thin film where the air molecule is in contact with the water molecule. This particular part is called as interface. Now, the physical forces experienced by the molecules at the interface is different than the physical forces experienced by the water molecule at the bulk. So the water here inside, that is bulk. At the bulk, each of the water molecule is getting pulled uniformly in all direction by the other water molecule. But At the surface, water is being pulled more towards the water and less towards the air. As a result, you will find that it will form a U-shaped meniscus. Now this glass is little thicker. If you would have taken narrower tube like a test tube, you would have found that it forms a slight U-shaped meniscus. Why? One more interface is also there. One interface is of water and air. Another interface is of there, which is of water and the glass. So water and the glass interface is also there. Denser the object will be, more will be its adhesive force. So the water molecule loves to be adhered with the adhesive force with the glass molecules more. As a result, the glass molecule pulls the water towards itself, and the water molecule, among themselves, they are trying to pull each other, as a result of which it forms a U-shaped meniscus. But this is the case in which I have taken water as the liquid. What about if I would have taken mercury as the liquid? In case of mercury as the liquid, mercury is more denser than the glass, so its cohesive force is more in the metallic liquid itself than that of the glass. As a result, in case of mercury, convex meniscus is formed, whereas in case of water, concave meniscus is formed. Alright, so this is also a surface phenomena or interfacial phenomena. Surface, when I talk about one particular matter and its surface. But when two surfaces are in contact with each other, then that zone is called as interface. So these are all interfacial phenomena. That means formation of upper meniscus or lower meniscus, formation of concave meniscus or convex meniscus. Now look at this brush. Why did I bring it for? So this brush, if I will put it into the bulk of the water, see, it will spread. The bristles are spreading. The hairs on the tip of the brush are spreading. But the moment I will bring it at the tip, it will become pointed. Now I have somebody who can give me a feedback whether it is visible in the camera or not. So is it visible? Alright. Now see, it has become pointed. Why so? Now again I am dipping it. When it goes to the, it is going to the bulk, then again the hairs are becoming spread apart. But when I am taking it out, the brush is becoming pointed. So far this had been happening, but you might not have bothered. Why? Today is the time when you will feel bothered and interested to study about surface chemistry. Now what is happening here? As I told you that the water molecule at the bulk, they are getting pulled by each other uniformly. Now this is the water in the tumbler, and here each molecule is getting pulled uniformly in all directions. But at the surface what happens? Pull is more towards inward, even more towards the glass, but very less towards the air. So this is air, water and glass interface. So how many types of interfaces are there? Air, water interface, water, glass interface and water or air glass interface. Air glass interface. What interests us more is what we can see. That means air water interface, water glass interface, but glass and air interface does not catch our attention much, because air we cannot see and its effect also we cannot see on the glass, because mostly people see how much of water is filled in rather than how much glass is not filled in. Alright. So this was second thing. Now, did I answer you that why it was becoming pointed? No, I did not answer you. Alright, let me answer it now. So when I am putting the brush over here, this water molecule in between the hairs, they are getting pulled apart uniformly all around, as a result of which it is spreading. But moment I am taking it out, then what is happening? The cohesive force, the adhesive force between the water molecule in between the two hairs, in between the hairs, the water molecules which are there, they are attracting each other, as a result of which the hairs are getting adhered due to the adhesive force of the water molecule. So there is a difference in the adhesive and cohesive force in the surface and in the bulk. In the surface, this is surface, this is bulk, and between two surfaces, that means the bottom surface of the air and the top surface of the water, it is called as interface. For IT students, just like we say that the operating system is the interface between the hardware and the software, because hardware is somewhere and software is somewhere, and you are in between using the hardware and software. So that this word also has come from chemistry only. See, if two surfaces are, or two systems are there in contact with each other, then that we call as interface. And the interfacial phenomena is much different than the phenomena at the bulk. So that was the gist of the thing which you needed to learn in the introductory part of this chapter. Now, what are we going to learn ahead in this chapter? Let us see this. What is this? This is milk. Now I am going to call ghost. Alright, and to call ghost I have to put the lights off, otherwise the ghost will not come to drink the milk. Is that I am going to do? Alright, let's see what I am going to do. This is clear water. I will pass light through this using a torch camera. Alright, means the flash of the mobile, which is also used for the camera purpose, so that I will be using as a torch, and I will be passing through this. Then I will make this solution colloidal by putting milk into it, and then I will try to do it. So for that I will require a nice uniform background and the lights to be off. Alright, so let us see little bit of colloidal effect. Alright, so I have to put the light on. Any other source? Alright, so very simple experiment which you can also do at your home. So I am putting the flashlight on. Then we will try to see what happens to the light when I pass through it. Beautiful. It's acting as a lens now, because it is a refracting medium. Alright, so we will not deviate ourselves into optics. What I will do is, I will put the lights off. Alright, now let us see what happens. Here you will see that the light is passing through in straight line, mostly in straight line, isn't it? The light is passing through mostly in straight line, and it is not showing Tyndall effect. Now slowly I will make this true solution into colloid. So I will ask for a little bit of help from my friend who is there with me right now. So he will put the colloidal solution into this true solution, and then we will see what happens. See what is happening now. Now see, that light which was looking like a horizontal line, now it is getting scattered and it is becoming like spreaded light. It is becoming like a spreaded light, isn't it? And since the solution has also become translucent, so it is the light is not passing even properly. So what I can do is I can make it a little more dilute. So little bit of water from that bottle there. Alright. So I have tried to make it a little more translucent, and can you see the light now is forming? You see the focus here. The focus is so small. The focus is so small here. But here if you will see the focus of the light, it is wider. Now can I ask my friend to draw a circle on that focus?
It depends.
So if I am seeing the focus here, then you might be seeing the focus somewhere else. Alright? So although the light was coming from a very narrow lumen here, but you see that the light is becoming wider over here when it is passing through the colloidal solution. That means it is assuming a conical beam of light. So we will be studying about these properties of colloids also in the end of the chapter, and how easily we prepared this colloid. This preparation of this colloid was very easy. I had just taken milk powder and then I had dissolved it in hot water to make it milk, and then again I diluted that in the clear water and the colloid was formed. So the colloids which are easily formed are lyophilic colloids. I repeat, lyophilic colloids, which are easily formed because they love the solvent molecule. They are in love with the solvent molecule. As a result, such colloids can be formed very easily. But if I want to prepare colloid of, say, arsenic sulfide in water or H2S in water, it will become difficult. So in that case, we have to apply some other indirect methods. Now I have milk over here. Alright. Milk is now completely dissolved here. Now what if I want to purify this? If I want to purify this, then what will I do? I can do distillation, of course. But if I will do distillation, then what will happen? Due to the heat, the protein in the molecule will get coagulated. What is coagulation? Colloidal particles, when they aggregate together, then it is called as coagulation. So like when you prepare idli from the batter of pulses, then actually those pulses containing protein forms coagulate. It's called as coagulation. When you prepare paneer from the milk, the casein protein of the milk is undergoing coagulation. So you will understand about coagulation, then peptidization, all that in this chapter. So this was the introductory part. After this introduction and the experiment, which must develop quest and interest about this chapter in your life, I will start with the learning objectives which you need to learn. Shall I do it in the same video or next video?
Same video.
Same video?
Same video.
Will it not be longer?
No, I think we are having the quest very much.
Alright, but then very recently I have come to know that the students nowadays are just like goldfish. So they are not able to catch their attention for long. So, alright, we will do it. Anyways, I can always, split the videos. I can also join the videos. I've got so many tools with me. Alright. So the learning objectives, a few which we have already achieved and a few we need to achieve are. First, learning objectives. So what you will be able to do after learning this chapter, that is your learning objective. The first is that you will be able to describe interfacial. It's not the facial which you do in the parlor. It's interfacial, in between the face surfaces. Interfacial phenomena. Second, means between the two surfaces, between the two surfaces in contact. Second, adsorption. Is the spelling correct? What should be the correct spelling? So far you might have learned absorption, absorption, absorption. But from today you will also learn about adsorption, adsorption, adsorption. Adsorption means surface absorption. To make your learning easy, I have got these kits, so I can show you surface adsorption right away. Alright, I have this Pichku beaker, tiny beaker, and I have some colored solution here. Now I am putting this color in this beaker. It's nothing, it's not copper sulfate, it's not copper sulfate. Although copper sulfate also looks like this color itself, but it is not copper sulfate, it is simply color. Alright. Now what I will do is, a very good absorbent or adsorbent is there in my hand, the chalk. I will show you what is surface adsorption. I'll just dip it here inside and you will count 1, 2, 3.
1, 2, 3.
Alright, now I have taken it out. Now you can see the blue color on the surface of the chalk. So will this blue color be there at the bulk also? Let us see. You have to break it then. See, at the bulk the blue color is not there, but at the surface the blue color is adsorbed. At the surface the blue color is adsorbed. So this is called as surface phenomena or adsorption, not absorption. Adsorption means surface absorption. So why it is important? It is important to separate colors. You might have done some experiment in class 9th. If you have not done, I will show you it very shortly. Now I have got lots of kits with me and a few kits are going to come from Amazon. I will be able to show it right from my home, even being quarantined. Alright, so this also is there with that. Now next learning objective is physisorption and chemisorption. Physi-chemi. Physi means physical absorption. That means no chemical bond is formed. Chemisorption means when absorption has taken place, some chemical bond is formed. Which bond will be more stronger, physical bond or chemical bond or Febi bond? Alright, physisorption is a physical association, just like adhesive force. Obviously it has to be weak. It can be multi-layered. See, it is multi-layered. I was saying surface, but if I would have not counted 3, if I would have counted 30, I think that bulk absorption could have taken place. So adsorption is multi-layered, physisorption is multi-layered, but chemisorption is specific. Chemisorption is specific and it is unilayered. After the adsorbent, that means the surface which adsorbs, is filled up by the absorbate, right? That means the particles which get absorbed is filled up. Then there is no point why another molecule should come and find space in the area where no space for adsorption is available. However, due to some residual charges and van der Waals forces available, second layer of absorption could also take place. But the extent is not that as much as it is in case of physisorption. In physisorption, adsorption could be multi-layered. In chemisorption, the adsorptions are mostly unilayered. Now, when adsorption takes place, at that time, bond is forming. Why bond forms? To get stability. When stability will be there, then heat will be released. That means some heat of chemisorption will come out. Since the bond of chemisorption is stronger, so stability is stronger. If stability is stronger, then more heat will come out. So the extent of chemisorption is more, and the heat of chemisorption released in chemisorption is more as compared to physisorption. So this also we will study in detail. So there will be a 3 marks question. Differentiate between physisorption and chemisorption, and then we will tabulate and we will write down the notes of that also. But today we are just introducing ourselves with the learning objectives of this chapter. Next is mechanism of the adsorption. Mechanism of the adsorption. Mechanism means steps followed. Steps followed. Steps followed means process followed. So instead of writing 2 words, it's good to write 1 word. Mechanism of adsorption. So mechanism of adsorption is very easy. What happens at first? The adsorption takes place between adsorbent and adsorbate. This was adsorbent, this was adsorbent. Adsorbent, adsorbate. The one which gets adsorbed is adsorbate. The one on which adsorption takes place is adsorbent. Now, what has happened? The adsorbate walked through or ran through the adsorbent, and after that what happened? A bond was formed between the surface of the adsorbent and the adsorbate. This bond could be van der Waals force of attraction. This bond could be due to adhesive forces. So whatever the force of attraction could be, due to that some kind of adsorption takes place. Now when adsorption takes place, at that time heat is released. But if we leave the adsorbent and adsorbate for some time, it may absorb heat from the surrounding, and the particles adsorbed may experience entropy, randomness. Due to this randomness, it may leave the surface of the adsorbent and desorption can take place. So for adsorbent, heat is released. For desorption, heat is adsorbed. Means if heat is absorbed, then desorption will take place. If heat is released, then absorption will take place. Now tell me the 2 conditions required for having hydrogen adsorbed on the surface of platinum and nickel. Should the temperature be high? Should the pressure be high? 1, 2, 3. Goldfish, pay attention. Come. Yes. So when you want to adsorb any gas on any metal surface, the pressure on the gas should be high, obviously. Second thing is that the temperature of the surface should also be optimum, so that it does not get desorbed. Otherwise, at high temperature, the molecules, the gaseous molecules will have high degree of randomness due to kinetic energy. You know, this kinetic molecular theory of gases that you have to relate here. Alright, so that we will be studying here in case of mechanism of the adsorption. Then comes isotherm. As I told you about the relation of temperature with the amount of adsorbate getting adsorbed in the adsorbent depends upon temperature and pressure. So that we will be studying about in case of Freundlich adsorption isotherm. So we will be studying about how much of adsorbate gets adsorbed in unit quantity of adsorbent and its relation with the pressure and the order of adsorption, where n should be greater than or equal to 1, so that it is a fraction. So this relation will again become x by m is equal to k p to the power 1 by n. Based on this, we will draw 2 graphs in which we will be drawing graph between x by m and the p to the power n by 1 by n, and also the logarithmic form in which it will become a linear equation instead of exponential equation. Alright, so this also we are going to see. Freundlich adsorption isotherm gives the graphical plot between the adsorbent and the adsorbate and its relation between its relation with the pressure exerted on the gas molecule while it gets adsorbed on the metal surface or solid surface. Then we will be studying about the nature of colloidal particle, in which you have already become master by now. We will be studying about emulsion. Liquid in liquid is called as emulsion. So a liquid mixes with another liquid. What happens? Either this beautiful process which is taking place is called as diffusion. See, spontaneous intermixing of two particles is called as diffusion. I am not styling it. Am I styling it? I am not styling, but it became blue. Now more color if I add. I'll just simply add color and the color will get diffused on its own. It will mix on its own. It is spontaneous intermixing. Now see, the blue color is becoming more intense. I am not styling it also. So this is spontaneous intermixing of gaseous particle or liquid particle or fluid particles. Fluid particles are the particles which can flow. It could be liquid also, it could be gas also. So they spontaneously mix up and without any external effort. So we'll be studying about the colloidal nature, means how colloidal particles are formed, how colloidal solutions are formed, what are the uses of the colloids, how they can be separated. Alright, that we will be studying. And how gel is formed. Gel, what is gel? I'll not show the brand, now people will scold me. What is this? You know all. This is a gelatinous adhesive. This is gelatinous adhesive. It contains more solid than the liquid. So here solid is solvent and liquid is solute. So it forms a gel and it is a colloid. So this adhesive property is also due to its colloidal property. Forget about any branded adhesive. Even if you take wheat flour, that can also act as adhesive if you make it gel. If you take corn flour and if you make a gel of that, that can also act as an adhesive. I remember when I used to bind my books, I used to take maida. So that maida is also very sticky. That is why it causes constipation also. So if you mix that with warm water, it will also become adhesive. So you know how to make gel. Take more amount of solid solute and less amount of liquid solvent and mix them. If it is a gel, it will act as an adhesive. It will have adhesive force. Alright. So we'll be studying about these properties of colloids and how they can be used. Then this emulsion was very easily formed. Because it was also water based. This milk was also water based and this color was also water based. So it mixed up very well. Emulsion could be of two types: oil in water emulsion and water in oil emulsion, or water in water emulsion, oil in oil emulsion. So if oil is mixed with oil, then they form miscible liquid. If water is mixed with water, they form miscible liquid. So there is no question of being emulsion or something. But if oil is mixed with water and water is mixed with oil, what's the difference? Yes, there is a difference. When I say oil in water, that means oil is less, water is more. Oil in water. Water is more, oil is less. Example, milk. But when I say water in oil, that means water is less, oil is more. Like in case of oil paint. So these are the two types of emulsion. W by O or O by W. Water in oil or oil in water emulsion. So when two immiscible liquids are mixed together, then we call them as emulsion, and emulsion could be of two types: oil in water, water in oil. Do you think the chapter is complete? No. This was just the overview. Now I will split the hairs of each topic day by day, and I will make elaborated videos of each and every paragraph of your book, so that no topics are left unturned for your preparation for the board exam. So stay tuned, subscribe, like if you have liked, give me personal comments, No need of giving comments on YouTube. If you can give, it's alright. If you don't want, you can give me a personal comment and remark so that I can get motivated and energized. But your silence kills me sometimes. So if you are watching it and if you think it's benefiting you, let me know. Thank you.